Hello there. Welcome to our today's science lesson. The topic for the day being chemical formulas for compounds. An overview of our previous lesson is that we talked about chemical formulas of compounds just like today, but in the previous topic we narrowed down to compounds that have only two types of elements, where we saw that in naming of those compounds that have specifically two types of elements in a compound, there were rules to be followed. The same rules have to be followed, but it always doesn't apply to all compounds. The rules were that in that compound, the first element should always have its full name given. But when it comes to the second element, part of the name is adopted in addition to a prefix or a last addition of IDE. However, we also had another inclusion, and the inclusion came in because of the variation in the number of atoms that will be present in that compound. You may be talking about an element of a particular, an atom of a particular element, but that element has more than one atom. That element has more than one atom in that single compound. You always have to indicate that number of atoms in the name, and this was taken care of by prefixes that range from mono to deca. Deca meaning 10 and mono meaning 1. We did so many examples on that aspect, and we saw indeed the formula and the name were in agreement. But to link the two, that is the formula and the name, the ratios of the atoms or the ratios of those elements in that particular compound were first of all supposed to be identified, which we did. In the introduction of that very last topic, I mentioned that as much as the chemical formula and the name are in agreement, so long as the rules are followed, I also said that we have compounds that the name and the formula cannot really match directly. You cannot just say, since this is a dioxide, then you will see it in the formula. No. And most of those compounds are found to have more than two types of elements in the compound. We shall also see cases of compounds that have only two elements, but we will also be deviating on that rule that we saw in the earlier lesson. This will also take us to a point of introducing another new aspect in the compounds, or another aspect in the naming of those compounds. So just to start off with what we have today, we want to look at how to write chemical formulas of compounds, but in particular, these compounds will be having more than two types of elements. So we shall have more than two types of elements in the compound. Now an example, just using letters, if we have a compound having a letter A, represented by A, and maybe we have another one K, and we have a T, these are letters standing in for three different elements. Then this type of compound, for you to be able to name, you cannot apply the rules as was stated in the previous lesson. In the previous lesson, we could only talk about maybe an A and a K, where A will have a full name and the K will have a partial name. Then you add there IDE. As long as you remember how many K you are having in that particular formula. But today we want to look at a case of 3 elements in one single compound. You cannot say maybe A, let it be full, and this one half, half. Which rule will it be following? Since we don't have a particular rule for that, and the reason why we are soon going to get it, we want to look at how to name these compounds. And it's good if we can have particular examples so that we can try to name using the previous way of naming the other compounds, fail, then see how we can go around it. So if I have a compound, for example, sodium carbonate. This is a name of a compound. In this name, we have sodium. In this name, we have carbon. And in this name, we have oxygen. These are 3 different elements. But looking at the name keenly, it can easily bring a confusion, such that the name sodium appears and it is in full. Probably it is agreeing with what we saw in the previous lesson, where the naming of 2 types was so clear that the first element, full name. But look at the second one. The second one is carrying these 2 elements, carbon and oxygen. Carbon can be seen. Carbon can be seen. But where is oxygen? Oxygen is not appearing anywhere in the name, whether as a full name or part of the name. But looking at the formula, oxygen is present, and in fact, it has more than 1 atom in this formula. When we shall be writing the formula, formula of sodium carbonate, you will realize that sodium will be 1, will be 2, carbon will be 1, and oxygen will be 3. But in the name, the oxygen is not appearing. What does this one tell us? It tells us something to do with how these compounds react. When chemicals are reacting, we have groups of some particular atoms that always remain together. Groups of atoms, whenever any compound is reacting, there are some cases where particular atoms always remain together as a group when a reaction is going on or is proceeding. This type of group of atoms are called radicals. Such atoms are called radicals. This type of atoms that always remain together whenever a reaction is going on are radicals, and we have so many types of them. These radicals have been assigned particular names, and the name will always go by the elements that are present in that particular radical. Maybe before we look at the so many radicals, let's look at an example we have just looked at, and that is sodium carbonate. Introducing the aspect of radicals, we shall now be able to understand why the name is this way, even if there is an oxygen and the oxygen is not appearing in the name. This second name attached to the first name, which is the metal present in that compound, the metallic element present in the compound will always carry the first name of that particular chemical compound. But the second part, which is having 2 elements together, these elements always operate as one group, which we are calling radicals. And these radicals, depending on the name or on the element that is present in the compound, they will always be given a name. So this second part of our sodium carbonate is a carbonate. The second part is a carbonate. This is a name that has been assigned to a group of atoms that always remain together as a group, which always carry that formula. That combination is always permanent that way. And the combination that we call a carbonate is a combination of one carbon atom, and 3 oxygen atoms. 1 carbon atom and 3 oxygen atoms. Anytime these 4 atoms are together as 1 carbon and 3 oxygen, will always be called a radical. And whenever a reaction is going on and there are these atoms of this element, oxygen and carbon, they will always remain as a single group. And since they are always there that way, then we are calling them radicals. And since they are always together that way, and in them we have carbon, then the general name we assign them is carbonate. Now, is there any format that has been used that will be always applied in all other cases when giving the name of a radical? And the answer is yes. All radicals will carry the last part of their name as ATE. All radicals in their last part of the name will always be carrying ATE. Just like in the naming of 2 types of elements in a compound, we saw an IDE being applied. In our case today, for radicals, we are going to add ATE. Then the first part of that name of the radical, the first part, this is the second part. The first part of that radical will always take the name of the first element in that radical. The first element in that radical in full. The first element in that radical and in full. Looking at our case for now, which is a carbonate. In the carbonate, the first element is carbon. So we have it in full, carbon. You can see it in the name, it is full, carbon. The second part will be an ATE. And since it is already known that whenever you get carbon as an element 1 and oxygen 3 of them, you will always call it a carbonate. So it will have already taken care of the oxygen, because it is a known thing that once you see 1 carbon and 3 oxygens, call it a carbonate. So there is no need again of introducing whichever way you can introduce it to show that oxygen is present, because for it to be called a carbonate, then it means it's a radical, and that radical contains 1 carbon and 3 oxygens, giving us now the correct name for sodium carbonate as, the correct chemical symbol for sodium carbonate as 2 sodiums, 1 carbon and 3 oxygens. Later, I will have to mention why these 2 is coming in. It has to do with something I mentioned much earlier in our previous lessons of combining powers. For now, we just want to limit ourselves to how do we get the formulas and the names where possible whenever we are talking about a compound that has a radical in it. So let's familiarize ourselves with the other radicals that we commonly interact with whenever we are talking about chemical compounds. And in having to know them, it will assist us to naming the various compounds that we shall also be looking at. So common radicals. The common radicals we have, starting with the one that we have just looked at, is 1, a carbonate. This one is called carbonate. Carbon, first element, then ATE. Sulfate. Sulfate. Sulfur, then ATE. Now, as you can see, I mentioned something to do with the first letter, the first element will be given its name. But in some other few cases, you will find that the name is never taken totally in full. And this one was good. We have an example before we give the really difference in the two cases. And these are good example of the case. In the first case, the first element is in full. Carbon is in full. But in the second case, sulfur is not in full. We have just taken a portion of it. So it is a mix-up. In some cases, we have it in full, and in some cases, we have partial. This one is adopted to make sure that you get a well-coherent name. If it were in full, for example, sulfur, then you add here, it could read sulfurate. Maybe because of the sounding of arate, it could give a wrong meaning of the formula you will be talking about. So the correct formula here is, name is sulfate for the radical. We have also phosphate. Phos. This one is not full, just like for the case of sulfate. But you can see at the end we are having an ATE as a common way of naming these compounds. So phosphate, sulfate, carbonate. We have hydroxide. 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 This one is a kind of a unique radical, which I need to bring it to your attention, that as much as it's a radical, that is two atoms of two elements, the element being oxygen and hydrogen, it is called hydroxide. Hydro comes from the aspect of being a part of water. It's a special one, and that's why, as you can see, even the naming is a bit unique. It is the only one that will carry the same special way of operation. Then we have hydrogen carbonate. Hydrogen carbonate. Hydrogen carbonate. Now this one is having, as you can see, away from these first four, this one is having three elements in one. The first element being a hydrogen, then a carbon, then oxygen. But these three elements operate as a single group, what we are calling a radical. So the name to this, we have to put into consideration the first way of naming, which is this one, carbonate, which is just agreeing with these others. Because if you look at this portion, is similar to the first radical we saw, which is a carbonate. We have only introduced another element, which is a hydrogen, but is not mutating. It is not destroying the formula of the first one as we know it. So the name of the first one must just be present, which is now the carbonate. So the addition of the new element is just given in full. So this one we call it a hydrogen carbonate. Hydrogen standing in for the new element we have added in, but the carbonate will be taking care of the other part as we know it. We also have another one as a sulfide. These three and these four, they are different. So this one is sulfite. Now, this one is also a unique one. As much as it is a radical, it is not ending with the ATE, but is ending with the ITE. I'm introducing the unique ones because these are common radicals which I'll always interact with. As much as we have partial rule that is applying to some, which we need to know, and that is ending in ATE, but we also have others that deviate from that. And the first one we saw is hydroxide, which is unique because of the name itself. Even the first one is not oxygen in full, neither is hydrogen in full. None of the two is in full the way we are seeing the others. And again, if you look at the arrangement, the first one here was phosphorus, sulfur, first one, carbon, first one. But looking at this, the first one is oxygen. But if you look at the name, the first one is not oxygen. So it's a bit unique. But if you look at these others, they still go back to the format of the first one, also comes in first in the name. So here we have a sulfite. This one also has another radical that has hydrogen in it. This is a sulfite. Now this one has an introduction of a hydrogen in it, giving it a name like the case of the first one of hydrogen carbonate as hydrogen sulfite. Now you need to realize that you may be having some other maybe reading materials on the internet. You'll find a case of sulfite being written as this, PH, not F. It is still okay. So we have the British way of looking at it and the American way of looking at it. They are all correct. So you may find sometimes PH is being used or F is being used for sulfite, sulfate, phosphate. At this part, sometimes an F can apply, but this one is not so common. The common one is in the case of sulfate and sulfite. So we also have another radical here by the name hydrogen sulfite. Now that we have known these radicals and how they are called, these are permanent names. So long as you get the formula written the way I've written, the name will always stand. But let's look at it in another way of forming a compound, where this compound is including any of these radicals in the formula. How do we name such a compound? How do we write its formula? So we want to write the formula and name the compound. Let's start with the first radical, a carbonate, though I did it previously, but we'll start with it. I have a radical by the name a carbonate. I combine it with another element, for example sodium, like the case we have just had. We shall have our compound being written as sodium carbonate. This is giving us a direction on what we are supposed to do when it comes to naming. When you combine any element, and in most cases, the other element that will be combined with the radical will be a metallic element. It will always be a metallic element. Or if it is not a metallic element, but a species or a radical that is positive. Metals are positive, non-metals are negative, generally. So, metals being positive, if it will not be a metal, then it will be another radical that should always be positive. And I haven't indicated it here because I want to introduce that radical that is positive. We have looked at the various radicals, and you have to put in mind that these are not the only radicals. We also have a special type of radical, which is a positive radical. When it combines with these other radicals, it combines as if it is a metal. It combines as if it is a metal. Just like as we shall be seeing a combination of these radicals with the other elements, as we shall be naming and giving the formulas. So the special type of radical I want us to look at is ammonium. Ammonium. This radical is referred to as ammonium. It's a radical that contains one nitrogen as an element, one atom of it, and 4 atoms of hydrogen as an element. Now, these radicals will always combine with the other elements to form new other compounds. Those new compounds will have to be given a name, will also have to be given a particular chemical formula. Let's give an example of a reaction, starting with the one that we had already talked about, and that is carbonate combining with the sodium to give us sodium carbonate. Now you can see it is much easier to name the compound. We are calling it sodium carbonate, not sodium carbon and oxygen. Remember, in the previous case we only had 2 elements, so it was easy. But in this case we are having 3. So the 3, it will be very hard, a little bit hard to name, though one can argue that in this radical we had 3 and it was so easy to name. Remember that the second part of it was easier to name because we took this one as a single unit, a group of atoms, a radical, a carbonate. So we only added in the hydrogen, then we call it hydrogen carbonate. So the same method of naming this radical is what we are borrowing to this point. Hydrogen carbonate. Carbonate, a radical. So this one is a radical. The radical, we have added there another element by the name sodium. So we call the added element in full as sodium. Then the second part will be the name of the radical, which is already identified by the elements that are in it. And the elements here are carbon and oxygen, carbon being the main one, so the center atom, so the name becomes sodium, which is for sodium, then carbonate. But we also need to realize that apart from the name, we also need to know the formula. We need to know the correct formula of this particular compound of ours, the new compound we have created from a radical. If you look at the formula, this is not the correct chemical formula of sodium carbonate. The correct chemical formula of sodium carbonate is 2 sodium atoms, 1 carbon, and 3 oxygen atoms. Now the question comes in, where are we getting that 2? Where is this 2 coming from? So we have to remember that in any reaction, every element or every compound, every molecule that is involved has its own combining power. Very important. Has its own combining power. And that combining power will be carried from one compound to another. You remember in the very previous lesson when I said that that's where we shall start from, the oxygen in aluminium and the oxygen in zinc was carrying the same aspect of combining power. So it's the same thing I'm mentioning here, combining power. So in this case of writing a formula, as much as you'll have identified the arrangement of the elements in that compound, you have gotten the name of the compound. The name will give you a skeleton of the chemical formula. As you have seen it, the radical has combined with another element, which is sodium, to give us sodium carbonate. From that, we can now get the name, sodium carbonate. But this name is correct, but we cannot carry the name as it is to make a formula and get always the formula being correct. Like in this case, the name is correct. Carrying the name to make a formula, the formula comes out to be sodium carbonate. But it comes out to be that this is not entirely the correct formula. There is a figure we have to introduce in, and that is these two. We need to understand where the two is coming from. And these two comes from what we call combining power of any particular element, molecule, radical, of whatever kind that is being involved in a reaction. So all of these radicals, and remember I said these are not the only radicals we have. There are so many. This is just an example. So all of these radicals have their own respective combining power, which I want to give based on the ones we have at the moment, so that whenever you are writing any formula, you also have to put into consideration the combining power of that particular element or that particular radical. So for our first radical, which is carbonate, the combining power is 2. For sulfate, combining power is 2. Phosphate, combining power is 3. Hydroxide, combining power is 1. Hydrogen carbonate, combining power is 1. Sulfite, combining power is 2. Hydrogen sulfide, combining power is 1. I need to mention something about these hydrogen, carbonate, sulfite. Even we have hydrogen sulfate. We also even have hydrogen phosphate. As you can see, carbonate had a combining power of 2, but its hydrogen carbonate is 1. Why? Because the combining power have also the aspect of being positive or negative. Non-metal-based combining powers are negative. Metal-based combining powers are positive. So, which we call oxidation numbers. So we can even here include this one being a non-metal-based radical. It will have a combining power, but if we are to categorize it as a positive or a negative, it becomes negative. Even this one, negative. Non-metal-based, negative, 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 and negative. So we have to understand how this one came into being and not 2. We have to understand that hydrogen, as much as it has characteristics of an nonmetal, when you look at where it is found in the periodic table, it is found in group 1, just like elements like sodium, potassium, which are metals. So because of that, it has a combining power of 1. This hydrogen has a combining power of 1, but when you look at it in terms of negative and positive, since it is found in the same group as metals, it is positive. So being positive, and the carbonate has a combining power of 2 and negative. So if you take negative 2 plus positive 1, negative 2 plus positive 1, it gives us negative 1. Hope you have done that mathematically. You have done the Cartesian plane. On the Cartesian plane, you will find that such arithmetics can be done. where you have -2 plus +1, you will get -1. So it gives the hydrogen carbonate a new combining power which is -1. The same applies to a sulfite. Maybe let's look at a hydrogen phosphate of this one. It will be hydrogen phosphate. Hydrogen phosphate. When you look at this, the radical here is -3. The radical is -3. The hydrogen is +1. So the combining power of this new formed radical will be -2. Why? Because -3 plus +1 gives you -2. This phosphate also forms another radical. It can form another one, which is 2 hydrogens and a phosphate. So in this case, phosphate has 2 types of radicals it can form when combining with the hydrogen, and another one is 2 hydrogens and a phosphate. So the same applies when calculating the combining power. The combining power of this new phosphate will be, this new radical will be, the phosphate is -3, hydrogen is +1, but how many hydrogen are we having? 2. We are having 2 hydrogens. So these 2 hydrogens, one having +1, then we shall have a total of +2. So +2 plus -3, we get -1. So the combining power of this type of radical is -1, or that rarely occurs. We also have this one, which is -2, and the main one here is -3. So we have seen 2 new things here. One, that when a radical combines with any new element, the name that comes out as the new name for the new compound is the new element, which is metallic, is given the full name, then you just add on the name of the radical. The second new thing we have discovered is, we have realized is, the name will always not give the correct formula. So when writing the formula, you also have to put in a new aspect of combining powers. And each radical has its own combining power. So when we are now introducing the combining power in writing the name, you have to indicate the combining power of the radical. The combining power of the radical on the new coming in element. That this element has combined with this radical that has this type of combining power. So the combining power of carbonate is 2. Sodium is coming in. So it is combining with carbonate with this combining power 2. The carbonate is 2. We also need to realize that you can also have another element where you will combine with the same carbonate, but that too will not be written. An example is, let's look at calcium combining with carbonate. The name, as we have said, is just direct. Write the name of the new coming in element, which is calcium, in full. Then the second part will be the name of the radical. Any radical here, it can be any radical. It can be carbonate, sulfate, phosphate, hydroxide, all of them. The writing will be just the same. So our radical for now is carbonate. And we are good to go. The name is correct. But we cannot carry the name as it is, and we want to create a formula. The formula here will be calcium carbonate. But looking at it, the formula here comes out to be correct. We are not going to even look at the combining power, but you find that the formula here is correct. What has changed? What has made calcium carbonate to be different from sodium carbonate, where we had to write a 2 on sodium? The answer here is again back to combining powers. So you have always to look at combining powers of both the negative part and the positive part all the times when you are writing a chemical formula. This shows that sodium had a combining power of 1. Sodium carbonate. In this one, sodium has a combining power of 1. Carbonate has a combining power of 2. Calcium has a combining power, this one is 1 and this one is 2. Calcium has a combining power of 2. Carbonate has a combining power of 2. So because these 2 and 2 being the same, they cancel out each other, making the formula to remain the way it is and is correct. But here, 1 and 2 are not the same. So we have to make sure that the positive part and the negative part are balancing. Here we have negative part. As we said, it is negative. And the sodium here is 1, giving us positive 1. And this one is giving us negative 2. They are not balanced. So to balance, we have to introduce the combining power of this carbonate to sodium, so that these 2 times this positive 1 can give us a total of positive 2, which will now be enough to cancel out negative 2, so that it can give us a formula of sodium carbonate. But here it turns out to be okay. Maybe let's use another radical that will shed more light on the formula, and that is a phosphate. Let's use phosphate as a radical. We have a phosphate that is reacting with the sodium, reacting with the calcium, and reacting with the aluminium. As I've said, all elements have or groups of atoms, what we are calling radicals, have their combining power. And the combining power for sodium is 1. Combining power of calcium is 2. Combining power of aluminium is 3. Combining power of phosphate as a radical is 3. Here is 3. But you need to realize that in any reaction, we have a combination of a negative part and the positive part. The metals here brings in the aspect of the positive part. The radicals are bringing in the aspect of the negative part. But these two must be in agreement in terms of the combining powers. They have to be equal. The positive and the negative must be equal to cancel out. So, if our phosphate is 3, our positive part here for sodium is 1. The formula will be sodium phosphate. We name the positive part first. So the formula is sodium phosphate, which is wrong. For us to get the name, it will come in so easily. Just give the name of the element that is coming in, the metal part, sodium. Then the second part, the radical part, phosphate. The name is done. Sodium phosphate. The name is sodium phosphate. But when it comes to the formula, it is different. The formula here, now you have to introduce in the aspect of combining powers, where we have said sodium is combining power 1 and the phosphate here combining power 3. So to balance, we have to make sure that the negative 3 must have a positive 3 this side to balance. But how do we get this positive 3 when the sodium is just 1? You bring in the combining power of phosphate and you just introduce it down here. So it's like you just cross. and you are good to go. Take the combining power of phosphate here to come here, and in case it is more for sodium, take it the other side. So giving us the formula for sodium phosphate as that one, where combining power of phosphate has been brought on a sodium, so that we can have positive 1 times 3, positive 3, negative 3, 3 being negative, now negative 3. If you add, you get, they have cancelled. So this one gives us the correct formula of sodium phosphate. Maybe let's look at calcium. That one is a bit unique from the other one, where we have combining powers as 2 for calcium and 3 for phosphate. So the formula here is calcium phosphate. Looking at it, the formula is wrong. Why? Because the combining powers haven't been considered. By name, we can give it the name very fast and easily. Calcium is the name for the new element, which is calcium. The radical is phosphate, so the name is done, calcium phosphate. But look at the formula. You also have to consider another aspect of combining powers. So as I've said, it is just cross the combining powers. If it is 1 to 1 or 2 to 2 or 3 to 3, they cancel out. If they are different, then introduce them separately. So the combining power of phosphate here is 3. Now the combining power of calcium is 2. How do we write 2? Do I write the 2 here? It will bring a confusion. It will now read as if it is a calcium, 3 of them, phosphorus 1, oxygen 42, which is wrong. So when you are crossing the combining powers and you are involving a radical, if a number will be or is supposed to be written outside the radical, then the radical must be placed in brackets. So we place the radical as it was originally P1O4, originally in brackets, to show that these 5 atoms, 1 phosphorus and 4 oxygen, are groups of atoms always reacting as a single unit, what we call radical. So this radical is put in brackets to show that it is one thing. Now this one thing has this combining power of 3. This one thing, which is calcium, has also a combining power of 2. To balance the formula, we just cross over. Combining power of calcium goes to phosphate. Combining power of phosphate goes to calcium. And now this one becomes the correct formula of calcium phosphate. Let's look at now the third one. Phosphate, combining power 3. Aluminium, combining power 3. How do we write the formula? Aluminium phosphate. The name is done. The element aluminium in full. The second part is the name of the radical, phosphate, and the name is done. But let's look at the formula. Combining powers must come in. What is the combining power of phosphate? It is 3. Combining power of aluminium? 3. What have we said? Just cross the combining powers and you are good to go. So the combining power of phosphorus is 1. I need to write here 1. Combining power of aluminium is 3. I mean 3 for phosphorus, 3. I need to write there 3. The combining power of aluminium is also 3. Being a radical, I need to place it in brackets. In brackets, so that I can write my 3 outside. But look at it keenly again. This is 3 and this is 3. Do you need to? No, because these 3 will cancel out. So leaving us with a very good option of not writing anything, because the 3 have cancelled out. This one being the correct formula of aluminium phosphate. Now, just to clarify further on the unique radical as we complete our lesson for today. You remember I said that there is a unique radical, the only one that is positive. All the others you have seen are negative. They have combining powers, yes, but in addition to that combining power, categorizing them as positive and negative, all the others we have seen are negative. All of them, apart from one, ammonium. We said that ammonium is a positive radical, and in fact, it is commonly found as ammonium ion. Ammonium ion, just to confirm that it is positive. Now, looking at it as a radical, it also has a combining power, and its combining power is 1. So that if you are to put in the positive and the negative, then it becomes positive 1. This radical can also combine with these other radicals. For example, we can have this ammonium combining with a nitrate, though we don't have a nitrate on this list. We have a nitrate, we can have a carbonate, and we can have a phosphate. This one will give us ammonium. So you just get the name of the radical, then nitrate to get the name. So the name of this plus the name of this, you get the name of the compound. The name here was ammonium. The name here, nitrate. Combined name, ammonium nitrate. But when it comes to writing the formula, you have to remember that combining powers have to be put into consideration. So the combining power of ammonium, as we have just said, is 1. The combining power of nitrate is 1. So being 1 and 1 being the same, then we don't need to write. So long as the combining powers are the same, you don't have to show the combining powers. So that is the correct formula of ammonium nitrate. Let's look at ammonium carbonate. Ammonium carbonate has been formed from this reaction. These are radical, these are radical. The name ammonium, the name carbonate, together ammonium carbonate, direct. But let's look at the formula. The formula, we have also to go back to combining powers. What is the combining power of ammonium? 1. What is the combining power of carbonate? 2. As I said, just cross over. When you cross, you have to remember that if it is a radical and you are writing there a combining power, then it has to be in brackets. So I need to write for the carbonate 2. For the ammonium, 1. Being 1, you don't have to show. So this one, I don't need to show. But these 2, I have to show it. But do I write it the way I've done it? The answer is no. Because it will read as if it is 42. So we put the original radical in brackets. The original radical as it is, ammonium in brackets. So that the combining power of carbonate can be written outside. This gives the correct formula of ammonium carbonate. And finally, let's look at phosphate, giving us ammonium phosphate, which is a good compound when it comes to agricultural activities. This is a fertilizer, phosphate. Again, by name, just take the name of the radical, ammonium. Take the name of the radical, phosphate. Put together. What is the answer? Ammonium phosphate. That is the name. But look at the formula. Is it correct? Putting into the perspective the combining powers, 1 for ammonium and 3 for phosphate. Is it correct as it is written? No, it's not. Because the combining power of ammonium and phosphate is not the same like we saw for ammonium nitrate. Phosphate is 3 and ammonium is 1. So we cross over. Crossing over, and since these are radical, we put in brackets so that we can have a 3 here. And since this one will be a 1, then there's no need of indicating, giving us our new formula for ammonium phosphate as this. So essentially, what have we been doing? We have been seeing that a name and a formula in some compounds agree. But in some, a name and the formula do not always agree. You have to put in another aspect of combining powers. We have also seen that whenever you are writing the names of compounds, look at the number of elements, the types of elements present in the compound. If there are only 2, then follow the first way we did when naming and even giving the chemical symbols, where you just give the name of the first element and the second one, identify the part of the name, then you add their IDE. But where we have more than 2, and in most cases you will find that where we have more than 2, then a radical is present. In most cases, where we have more than 2 types of elements existing, then you will always find that a radical is present. Where a radical is present, identify the radical by the element present in the radical, as you have done it. Get the name of the radical. That name of radical will give the second part of the name in any of those compounds that is containing the radical. Like we have seen ammonium nitrate, you can also say sodium nitrate, you can say aluminium nitrate, where the nitrate is the name of the radical, to avoid the issue of having now the 2 elements having to be named. That marks the end of our lesson today. Till next time, thank you.